What up? It's Kettle Hut, and welcome back. Yes, back to what? Another Alex homework help video. These are new for Algebra 1. I'm going to post this week mine and the one that Mr. Parsons has done. So we watch them both. His might be a little bit more in depth. This is cool. I just enjoy making these. So I'm going to do it as well. So let's hop straight into it then. Here's our Alex. Some of you, sometimes if the homework doesn't show up on the left side of the screen over here, you can always get to it by hitting the pancakes on the top, going to assignments. There they are. Today we're doing part 3 and 4. So solve for W. This looks like we're going to have a classic factoring problem here. More than one solution. So what we saw from part 1 is you can do this, move the thing to the other side, try and factor it, but notice we can't do that here because then we won't have only W's and have it equal to 0, so we can't use the zero product property or anything like that. So instead we have to factor. If you remember, to factor something, you need the X box, and the number that goes in the top up here is the first term multiplied by the last term. So in this case, 1 times 2 is 2. And then the middle term goes in the bottom. We have to ask ourselves, what are the things that multiply to 2 and add to 3? Well, the only thing that possibly multiplies to 2 is 1 times 2. So it has to be 1 and 2. And when we do that, double check. 1 times 2 is 2. 1 plus 2 is 3. So these are our two things that we want to care about. So if we remember from factoring, when we have them in the box, then this turns into x plus 1. And I'm getting a board soon, so that way I can write this, and it'll definitely be nicer handwriting. And x plus 2. And that equals 0. Now we can do the zero product property, which means you set each piece of this equal to 0 separately. So x plus 1 equals 0, and x plus 2 equals 0. And then to solve this, get x by itself, do the opposite. X equals negative 1. And then to get this x by itself, subtract 2 from both sides, and you get x equals negative 2. So the factoring, we've done this before. It's old news, but once you factor, then you can use a zero product property. As long as one of these two things equals 0, the whole thing will equal 0. The only way to make x plus 1 equal 0 is to plug in negative 1. And then the only way to make x plus 2 equals 0 is to plug in negative 2. You can also check these answers by just plugging them into here. So if you plug in negative 1 here, you got negative 1 times negative 1, that's a 1. Plus 3 times negative 1 is negative 3. So 1 minus 3 is negative 2. Negative 2 plus 2 is 0, so it works. X squared plus 6x plus 5, same thing. First number times the last number, 1 times 5 is 5. Middle number goes on the bottom, 6. What multiplies to 6? Sorry, it's always the top. What multiplies to 5 and adds to 6? Well, there's only one thing. 5 is a prime number, so the only thing that multiplies to 5 is 1 times 5, and then 1 plus 5 is 6. So if you were to rewrite this to use a zero product property, you have x plus 1, and then x plus 5 equals 0. And then you solve this just like we did. You set each one of them equal to 0. So x plus 1 equals 0. That means x has to equal negative 1. And then x plus 5 equal to 0. That means x has to equal negative 5. As always, you guys are welcome to use Desmos. Desmos definitely lets you cheese this a little bit more easily than this. The other way to do it is when you're doing the Xbox, if you're solving for the solution, it'll always be the opposite sign. So when a is 1, like it is here, you have 1 and 5. You notice our final answers are -1 and -5. So -1, comma, -5. The other thing to point out is on the last one was the same way. Up here we had 1 and 2, and then after we solved it we had -1, -2. So when you do the x box, and the x value is, or the a value is 1, that works out fine. Here's where things get worse. Notice now a value is no longer 1, which is why we've been paying attention. So the number that goes on top is this first term over here times the last term, but also notice this isn't equal to 0. So we even have some work to do in front of that. So first 4x squared minus 11x. To set this one on the left equal to 0, you have to move 3 to the other side, which means it's going to be -3 equals 0. You can change it to x, that's fine. Doesn't matter. Letters are letters. The x box is the same. You take the first a term times the last term, so 4 times -3 is -12. And then we have -11 goes on the bottom. So asking yourself, what multiplies to -12? It adds to -11. So you could do this. You have 1 and 12, you have 2 and 6, and you have 4 and 3. Those are all the things that multiply to 12. There's no more than that. So which of these could you possibly make add up to 11? Well, 2 plus 6 is 8. 6 minus 2 is 4, so that doesn't work. 4 plus 3 is 7. 3 minus 4 is negative. And so that's not 11. And then 1 plus 12 is 13. 12 minus 1 is 11. So that would be the ones that work. You know it's 12 and 1, and then the hard part is always going to be which one's negative. So if you test 12 times 1, it's positive 12, so that already breaks it. You need which one of these has to be negative. Well, we find that out by looking at the bottom number. This bottom number is -11. So when you add them, you need a negative number. That means the bigger one over here has to be negative. And you can just put a negative on each one and see which one gives you the -11. So now we have -12 and 1. Some of you might say, oh, look, now all of a sudden it's just 12, 1, because we are 12, -1, because we just said it's the opposite. But remember, you can only do that shortcut when this value is 1. So this a value is 4, which means now we have to go factor by grouping. So start by rewriting the original problem. You have 4x squared. You have 4x squared. And now this middle term, -11x, is going to be split up into -12 and 1. So there's -12x plus 1x. Notice this gives us, that's a plus, oh my goodness. So what you should notice is -12 plus 1 is -11. So then we just finish it with a -3 equals 0. So now we have, this is our new equation. This is equivalent to this. If you change the x's to u's, these two things are exactly the same. I just split the 11 up into 12 and 1. How do we know to do 12 and 1? Factor. This is where some of the other classes are using factoring by Punnett square. That might be the empty squares you saw in the notes. We didn't really use a whole bunch of Punnett squares. We're going to do factor by grouping. So we're going to group the first two together, and we ask ourselves, what do those two things have in common? Well, you can take a 4 out of both of them. So you take the 4 out, and then you can take an x out. So 4x goes out front. The only thing left over, 4x squared divided by 4x, is going to leave you with x. -12x divided by 4x, well, the x's cancel. -12 divided by 4 is -3. Then we're going to group the other two maybe in a different color. So the only thing that we can take out of here, well, they have nothing in common. So if they have nothing in common, you can always take out a +1. So we take out a +1. That changes that to an x, and then negative 3 divided by 1 is still negative 3. Now, when you factor by grouping, you'll know this has been successful when these two things match. If these two things don't match, reevaluate, see if you took something out prematurely, if you did something a little weird, right? So if those match, that means now your factor by grouping is simply going to be 4x, the thing in front over here, and the thing in front over here, plus 1. That's our first one. And our second one is going to be the two that match, which is x minus 3. This all equals 0 still. So that's factor by grouping. We've definitely done that, but now we're using it to solve. It's just reminding you these things are out there. They still exist. Now we do the new stuff, quote unquote, which is going to be setting these things each equal to 0, 0 product property. This one you can do right away. That's going to be positive 3. So now you see all these numbers we have over here are wrong, like we alluded to. Again, the opposite, when it's just x minus 3, it'll be the opposite. So if you plug in 3, you'll get 0. Over here, we probably should set it up. So you have 4x plus 1 equals 0. And then get x by itself, subtract 1 from both sides, and you're left with 4x equals negative 1. And then simply, to get x by itself, divide both sides by 4, and you're left with x equals negative 1/4. And again, if you do Desmos, we'll try it on the next one, but chances are you'll get a decimal. You'll have to either convert it to this or do the actual math. Checking our work. Done. So the question that we all want answered is there an easier way to do this? Turns out, yes, there is. So you just type this in. To get that caret, you can either use sorry, I called it caret, but you can use this keyboard down here and use these buttons, this one right here. Or you can do Shift and 6, and that'll give you the exponent. So you have x squared plus, and you do have to change it to x's for Desmos, otherwise it doesn't work. 3x minus 10 equals 0. It's already set to 0, so it's good. If you're plugging it into Desmos, I don't think you have to set it equal to 0. So here's our parabola. You can zoom out, you can manipulate this however you want to try and see where the hoop is. From our transformations of parabolas and things, you should know what they look like. This is facing up, right? So here, where it crosses, these are our two zeros. The first one's really nice, negative 5, comma, and where does it cross again? Oh, this one's really nice, 2. So, Desmos, life-saving. Same thing. So this one, the A value is not 1, or excuse me, the A value is 1, so you can do this the easier of the two ways. Here we go. Here's one that's a little weird. So I believe if you change those to x's, you can type that straight into Desmos, just as you see it. So 5x and then shift 6 squared plus 6 equals negative 17x. Yep. See? So here's our two answers. The first thing is pretty nice. You got negative 3, so that's quick. Now the other one's weird. It's negative 0.4. Now I don't think Desmos will take this, but let's try it. Oh! There you go. Don't even have to convert that to a regular number. I strongly recommend you learn how to factor. It's going to be extremely helpful in Algebra 2. When you get to Algebra 2, they're not going to necessarily let you use Desmos the whole time, and you should know what it is. So this says write a quadratic function f whose zeros are 5 and negative 6. If you watch the notes video, he does a very good job going through this, and I think Mr. Parsons will probably do a very good job explaining this as well. I'm just here to show you the cheese in case you want to do it quick and dirty. So a quadratic function f whose zeros are 5 and -6. This means when you plug 5 into the function, you're going to get 0. So the only way to make that happen is if you do x minus 5, right? Because if you do x plus 5, x 5, then you plug in 5. So then if you plug this 5 in for x, 5 minus 5 is 0. That's good. Same thing. The opposite of -6 is positive 6. And I think, this is curiously, I always use x, but what happens if you use a different letter? You use p, you can use x, it's fine. This is just for my own enjoyment. Be sure to use the correct variables. Oh! It tells you the function right here. I didn't see that. The function is f of x. So it tells us we have to use x right there. I didn't even realize that. I didn't read that. I just saw a function of f. So there you go. Those ones are even nicer. So we can just knock those out real quick like. Quadratic functions whose zeros are, so again, you're going to rewrite the same thing, you're just going to do the opposite sign. So it's -2, so you put +2. It's -11, so you're going to put +11. Being sure to, now we do have to check, this is also f of x, so we do have to use x. Okay, so here's the different one. Write a quadratic equation whose roots are 4 and -6. It tells us to use x. So again, if the roots are 4 and -6, that means those are the zeros. So you have to do the opposite, x minus 4, 4, and then x plus 6. But the difference here is the leading coefficient is 5. So if you watch the notes, what we want you to do is plug this in here with an a, so put an a, and then go through and solve the whole thing and try and figure out, or graph it and try and figure out something else for that, for the a value. Am I thinking of a different type of problem? I am. How does he do this one on the notes? I don't know if this is like the notes. So, see, you can see what Alex is alluding to here. They want 5x squared plus 10x minus 120. They want you to multiply all this stuff out, and then the zeros would still be these. However, it realizes that what we typed out here is exactly the same as this. So if you multiply what we typed out, it's the same thing. The leading coefficient, you just have to multiply that in there on the outside. So you could put it here, you could put it on the front. It doesn't matter. So here, first things first, we're going to leading coefficient 2. So put that in first so we don't forget it. And then we know the values are going to be the opposite. So plus 3 and then x minus 4. And it's probably going to tell us, oh, you could do this, but oh no, it took us C. So I wonder if the other one would take it too, if we just, it wouldn't complain as much. Let's try putting it in front. X minus 6 plus 3. Yeah, so it complains less. If you put it in the back, it makes you want you to multiply it all out. Number 5, easy way to do this, just Desmos it or factor it. We'll do it in our head real quick. Factoring, what multiplies to -8 and adds to -2? 1 and 8, 2 and 4. It's got to be 2 and 4. -4, positive 2. So it's going to be x plus 4, x minus 2. Sorry, positive -4. So 4 and then -2. There you go. So yeah, again, I'm going to post this video along with Parsons's video. Is it Parsons' video or Parsons' video? Anyway, we're going to post them both. Go on there, see which one you like. His is probably going to be a lot more in-depth. Again, I'm just doing this because it shows you maybe a couple of different ways to do it. Also, I just enjoy doing it. So thank you for watching. We'll see you next time.